Hello, welcome to Coverings. Hope you guys have had a good morning so far. And we welcome you to this session, Nurturing Well-Being, Exploring What's Next in Healthy Building. We have three excellent panelists who will share what their organizations are doing, and we can take some questions at the end. Hopefully you guys have some lively questions. With me to my left is Luam, Melake, and Holley, Henderson, and Laurel, Chądyzński. Got it. Okay, just wanted to make sure. And I'm going to start by letting, who's speaking first, did we say? Luam. Mm-hmm. Perfect. So I'm going to let Luam introduce herself and go from there.
Okay, I'm going to go to the slide here. Yes, it's up. I don't think she needs it. Okay, hello. Welcome, everybody. My name is Luam Melake. I'm a senior researcher at the Parsons Healthy Materials Lab. And we are, sorry, just one moment, actually. Do you need this? No. Well, how do I see the speaker's notes? I don't use this program.
Healthy, not functional.
Okay, so they're here.
Oh, got it. Okay, there you go. Cool, thank you. Sorry. Okay, so the Healthy Materials Lab at Parsons is where I work, and we are a research lab dedicated to putting people's health at the center of design decisions. We raise awareness about toxics in building products, and we create resources for designers and architects. And if you go on our website, we have a vast array of resources that sort of translate science into design and sort of actionable decisions that you as designers can make. We work with a lot of experts from a range of fields and in order to develop those resources, and our focus is to improve affordable housing. So if we are what we eat, we are also where we live, because like all living things, we are products of our environment. Materials that are used to make rooms, buildings, cities, objects, furnishings are absorbed by our bodies and integrated into our biological systems. So the decisions we make about our environments directly affect our bodies. According to the CDC, genetics accounts for only 10% of diseases, and the remaining 90% appear to be from environmental causes. We work with an organization, or we partner with an organization called the New York City's Mount Sinai Institute for Exposomic Research, which studies the presence of chemicals in our bodies. And their research reveals that many industrial chemicals are present in human blood and urine, and many of those chemicals are linked to harmful diseases. And the way that they work is they've mapped it out according to like where people live, and unsurprisingly, a lot of the people who are most affected by the industrial chemicals that are in their bodies also live in affordable housing, which is why as an organization we focus on affordable housing. So we assume that materials and products that we buy have been tested for safety. However, in the United States, most commonly used chemicals are not tested or regulated for their impact on human health or the environment. There are more than 86,000 chemicals in consumer products, and actually only 250 of them have actually been tested for human safety. And the last time there was a major chemical legislation passed was in 1976, and it actually grandfathered a lot of chemicals into a safe space, basically, for them to continually operate. There are only 5 chemicals that are partially restricted, and that's why as architects and designers we need to be vigilant in assessing the materials we specify and look for material transparency. So plastics, polymeric materials are in the highest growth areas in materials products. Plastics life cycle is responsible for about 10 to 13% of global carbon emissions. Or at least we're expecting it to be. And we're surrounded by synthetic materials made from plastics, and these materials not only contribute to greenhouse gas emissions, but also can be toxic for workers and for end users, depending on their chemical makeup. So one example of a material that we do not advise you to use is luxury vinyl tile, which is made from PVC vinyl. And this seems like a simple product, but it actually has a lot of material, has a lot of problematic elements to it. The entire supply chain is really bad for vinyl, and this is a huge market area because over 5 billion square feet of this product is imported into the US, and it's present all over in every kind of like institutional setting, residential setting, commercial settings. And when you really look at what it's made of, it's almost entirely derived from petroleum. Most are entirely derived from petroleum. And what you get from that are a range of toxics, including phthalates, oftentimes antimicrobials, solvents. So these are problematic materials because they are linked to cancer, to neurological problems, to hormonal problems. So, and it's a material that covers a broad surface area. So there's a lot of potential for exposure here. So flooring alternatives such as natural stone, clay, flax-based linoleum as a resilient floor alternative are significantly healthier options. So here's a list of simple questions that are becoming incorporated into our teaching and into the practice of design that you should ask as you're considering a material to use. So what is it made of? Is it a natural material? Are there lots of components? Is it petroleum derived? How is it made? Is it made using renewable energy, which would be a great way to make ceramic tile, for example? And also thinking like, is there recycled content in it? Where is it made? So where exactly is this supply chain coming from? And like who's affected, which communities are affected by the production of this material? How will it be installed? So like what are some potential ways that you can like design for disassembly, for example? Or are there lots of chemicals being used in the installation process? Does it require finishes or adhesives, which are often toxic? There's a lot of water-based adhesives and finishes and sealants that are coming out now that tend to have more natural materials in them, which is better, less PFAS, less phthalates. Where does it go at the end of its useful life? Can it be recycled? Does it biodegrade? And who will be exposed throughout the entire life cycle? So these are very important questions to assess after you've looked at what a material is made of. So we advocate for material transparency and use a very holistic lens to analyze how materials affect different environmental, health, and social aspects through its life cycle. So this is an example of a framework of thinking about each different facet and how those facets interact when you're assessing a material. There's a material health component, of course. There's the social element of like who's affected in the communities. Waste, of course, is important. Water, circularity, carbon. We're in the process of aligning this and harmonizing with Laurel's organization, Mindful Materials. She will talk a lot about the Common Materials Framework, and we are also in the process of aligning with them. And so when we think about life cycle, it's not just like the user and then the trash. It's the process of the raw extraction and who's involved in the transport of that, who's involved in the manufacturing of that and the use, and like how does all of this affect the environment and the people who are involved in their health. So here are some tips for designers that hopefully make this less daunting as like you're trying to make better decisions in your material selection. So consider simple materials. It's kind of like the nutrition facts on food. It's like if it has a bazillion things in it, it's probably not good for you. And that's also true for design materials. So, more easily understood materials usually means less processed and easier to reuse and recycle potentially. Simplify the overall palette. You can do a lot of creative things using the same material in different ways in a room. And fewer materials also means less research time, and you can make more intentional, thoughtful decisions about materials that you're including in a process. You can also potentially avoid finishes and layers that might introduce more toxic chemicals. And also, like if you have a lot of surface area, you can it's potentially easier to disassemble and reuse the material that you're using for another project. Because if it's a small amount, it might not be worth it, but in a large quantity, it might be. And designing for disassembly is a great one, using mechanical fasteners and joinery rather than adhesives, which are often toxic, because then, at the end of the life of this space or when you're renovating, you can just take the material back. And then I just want to make some comments about our resources that we have available. We have a materials library that's open to the public at Parsons. You can make an appointment and come and see lots of different design materials that have been vetted for health and safety and environmental impact. This is like the main thing I think that's useful that we do is we have vetted material collections on our website. We go through a very, very rigorous process of vetting materials. It's a very high standard, and you can find materials relevant to stone, tile, to all sorts of things on our website. We also do courses in education, including a certification course for architects and designers, which is really useful. It sort of fills the gap in a design education that it gives you that material science component that often is left out of education. There's also free content on our YouTube. We have a podcast called Trace Material, which is really interesting about cultural history of materials. And we do events. We do talks with experts, which are usually really interesting. And we have a book that just came out, Material Health Design Frontiers, where you can hear from experts in the book. And you can check out our website, healthymaterialslab.org, for a jungle of more resources, lots of information, and thank you so much for listening.
Great.
So I think Bill's going to pull mine up. Hi, everybody. I'm Holley, and I'm with Chemical Insights Research Institute, or we call ourselves CIRI for short. And you might notice in the lower left-hand corner of the slide, the little UL circle, which oftentimes we see at home on our electronic appliances. So you may not know that UL is actually divided into 3 organizations now, completely separate leadership and completely separate organizations. There is the for-profit that still does testing and certifying. It's called UL Solutions. There is the 501c4 that's like a lobbying organization focused more on standards. And then there's UL Research Institutes that focuses only on public safety. And they have 5 research institutes within that 501c3 nonprofit, and we are one of them, series focused on human health. So with that, a couple of our research initiatives, and people often ask me, where do you get your research initiatives? How do you decide what you're going to research? Often it will come from people just like you. So it could be a consumer, or it could be a school teacher or a school nurse who says, you know what, we notice when we run the 3D printers in the classroom that the children with asthma actually have a reaction. So is there something wrong with the 3D printers, and we're melting plastic, what's happening? And so we're doing research around those types of emissions, but we're also looking at e-cigarettes and vaping, furniture and flammability, looking at flame retardants, global air pollution, PFAS exposure. And when I say PFAS, I mean forever chemicals. You might have heard of those in the news recently. There's a lot of research happening right now, especially in PFAS in our water. Our research is a little different. We're taking a different approach, a unique approach, looking at PFAS in textiles. And yes, that means yoga pants. And so today we're going to be talking a little bit about building resilience. So we're going to look at climate change and how that's impacting extreme weather on our materials. And then we're also doing toxicology and wildfire emissions. So the most important thing to us is the storytelling of the science, because as Luam was saying, you know, looking at research and trying to translate that to our industry is a real challenge. And so we want to look at that entire research to impact continuum. So we want to conduct the research with the right research partners and other industry partners. We want to publish our findings, and so those publications might happen in journal publications, or it might be an architectural record. It could be anywhere. And doing presentations like the one today, but we also create webinars and e-learning and all these things to try to help raise awareness around some of these human health impacts that we're finding in our research. So let's talk a little bit about the new research we're doing on material resiliency to climate change. So why is everyone talking about resilience? Well, when you see this map of the US, you'll notice there's 28 different circles that are all focused on extreme weather events that happened last year. So they could be everything from extreme heat to drought to hurricanes, tornadoes, you name it, wildfires. And each one of those is $1 billion disaster. So we know that it's having a huge economic cost. But we also realize, as all practitioners in the built environment, it's also having an impact on our built environment as well. So when we think about external stressors, the ones we typically think about are high winds, storm, fire, extreme heat, snow, and flood. We don't often think of those internal stressors that are things like chemicals that are happening in our spaces, or mold, or particles, temperature, humidity, dust, and allergens. But when you think about them together and what happens as a result of extreme weather, even if you don't have any structural damage with your exterior of your building during an extreme weather event, the building materials can behave differently. And so when we have those extreme weather events, and you might have a power outage where you don't have a conditioned space, or you have water intrusion, we begin to really see some impacts on the interior of the building to all of us. Now, when you have structural damage on the exterior, you might experience, the need for debris cleanup, hazardous waste, whether it be air quality or water quality hazards. We also see an opportunity for replacing those materials with materials where we're thinking about resiliency. So we know that all of these stressors have impacts on our human health, everything from extreme heat, related illness and death, cardiovascular issues, asthma, allergy, water-related and food-related, pathogens and infections, drowning and injury, as well as just stress-related disorders. And we know that disproportionately that impacts sensitive populations. So that could be children who have a faster breathing rate, they have a lot of hand-to-mouth behavior, the elderly, pregnant people, lower socioeconomical communities. These are all sensitive populations that have a bigger impact on their human health. So what we know, and this is, how many of you guys were in the earlier session? Earlier session was awesome, by the way. And what we know and we heard in that session is our current sustainable design approach really looks at, how tight is our building envelope? Can we make really energy efficient systems and use energy efficient fuel sources? And can we also lower our carbon emissions? Those are the big goals for sustainability, and they have been for some time, and they're amazing goals. And I thought they did a great job earlier. I'm going to ask that we look at another aspect, and we add a new aspect to that equation so that we don't have any unintended consequences. So when we're looking at the lifespan of a building, and we're thinking about the climate change and how the weather impacts may change over the course of that building, can we also add to that, in addition to airtight and energy efficient and reducing our carbon, also looking at the human health impacts from a resiliency standpoint? So we also need to think about the big billion-dollar events that we saw on the map earlier, but we also need to think about those small, everyday moments that are kind of our new normal with these new weather patterns. So it's time to be more reactive, let's not be reactive, let's be proactive, yes. And so that's why we're doing some research. This is a picture of our lab out in Marietta. It's close to Dobbins Air Force Base. You guys are all invited. We'd love to show you how our research works. And we're doing some new material resiliency to climate change research. So let's look at this. We know that these new conditions and stressors are creating new material responses, especially in unconditioned space. Now, you might have unconditioned space for a variety of reasons. Recently, we had someone from a Vermont school that reached out to us and said, we don't have central cooling, but yet we're finding that because weather patterns are changing due to climate change, we're having over 90-degree days. Is that an issue? Question mark. You also might have a power outage. You might not be able to pay your power bill. Or I even have a really good friend who is an architect who's retiring and just built a passive house. And he said, we really were not concerned about higher extreme temperatures because we like it hot in the house. And he's like, now I'm worried now that I've seen your research. So we're investigating these things. So we did some recent weatherization studies, and we took common building materials, and this is things that you would find in any common modern house or home, ceilings, walls, flooring, right? And we looked at it in two conditions. We looked at it in the ambient temperature, around 73 degrees Fahrenheit, and we also looked at it around elevated temperatures, 95 degrees Fahrenheit. And here's some of our findings. Two pieces we looked at. We first looked at frequently detected chemicals, and then we also compared those with regulatory and toxicity criteria. And here are some of our findings. So if you look at the total VOCs, or volatile organic compounds, and the total aldehydes, a common aldehyde that you've probably heard of is formaldehyde, in these elevated 95-degree Fahrenheit conditions, on the left-hand side, your left-hand side, the TVOCs, you see the materials and the percentage of increase, and then you also see an increase for the total aldehydes. But what we really noticed was that the flooring in particular had some real increases. So what this says to us is some of the current certifications that we're doing that are looking at total VOCs may not be applicable to the expanding real-world scenarios and applications. So we have to think about that now. With extreme heat, there's also increased pathogens, mold, other environmental factors that we need to think about that are influencing our interior material selection. We're also noticing that there's more wildfires. So when a wildfire happens and it's burning in nature, there's certain emissions that occur, and those are harmful, of course. But when we have this wildland-urban interface and the wildfires meet our buildings that are filled with synthetic materials, we have a whole different emission profile and a lot of different exposures. And so there's not a lot known about that right now, and we're doing a lot of study and research on that, and also chemicals of concern like the PFAS we mentioned earlier. So when we're designing for the future, any of us as building stewards want to think about a more integrative design process, and proactively evaluating potential impacts, thinking about the region that we're in, and if there might be some extreme heat scenarios, and then also continuously conveying those strategies, but assessing those outcomes as they happen. And then finally, I'd just like to mention, if anybody wants to learn more about the research findings, please join us this Wednesday at 9:30 in room B308. I'll be co-presenting with ASID, who we just jointly released a brief about this topic, the emerging issues, the connection. We have a little bit of guidance in this brief, and we're doing a whole second phase of research, and we'll have another brief coming out this fall that will give more guidance. I know, it's free. It's on their website. You don't have to be a member. It's on ASID's website if you'd like access to the brief. And then please join us on the socials and our newsletter and the website. Thanks, guys.
All right. Thank you, Holley and Luam. I think based on what we've just heard from both of our presenters, it's very clear that the impacts of materials in the environment are absolutely massive. So by way of introduction, so my name is Laurel Chądyzński. I'm the VP of Engagement at Mindful Materials, but I'm also a licensed architect and sustainable design leader at a firm in Boston where we specialize in corporate interiors. So I have kind of experience from the design and specifying side and also kind of from the industry scale. So I don't think I'm alone. I'm curious, how many folks on the design side are in the room today? Okay. So I would say, I know I can say this for Tori, that I don't think I'm alone in saying I want to feel confident and I want to feel good about the design decisions that I make. We want to feel that we're making a positive impact with our designs, right? But it can feel really overwhelming and hard to know where to start. We just heard a ton of different impacts of materials. I'm about to tell you even more. And there's a massive quantity of eco-labels and certifications out there. It can get very confusing. In fact, there are over 600 different sustainability certifications used in the market today to evaluate products and buildings. And most design firms, and certainly sole practitioners, really don't have experts on staff to know how to interpret all of these different standards and certifications. So how do we make sense of these? And what do they tell us about the materials that we're selecting? So let me introduce you to the Common Materials Framework. The framework, at its highest level, outlines 5 areas of impact, which are directly aligned with the impact areas identified in the AIA Material Pledge. So if you're not familiar, the AIA Material Pledge was created in 2019. There are today over 250 signatories, both large firms that you've heard of that are operating internationally, like Gensler, all the way down to, again, sole practitioners and individual designers. So again, over 250 signatories that have signed on to this pledge that essentially states we are committing that we are going to prioritize products that reduce their impacts on human health, climate health, ecosystem health, and social health and equity, and support a circular economy. And this pledge was certainly not the start of this conversation. It was represented momentum that was growing throughout the industry. And it really just, I think, was a tipping point in the industry. And now all of these firms have signed on to this pledge and signed on to this commitment, and we're seeing more and more designers and specifiers asking for things from manufacturers, asking for product transparency, asking for optimization. And we've seen that, more action, no matter how well-intentioned, if it's disconnected and fractured, not aligned, it just leads to more market confusion. It makes it very hard. I know many manufacturers that struggle with kind of responding to all of these disparate asks from designers, owners, procurement departments, all asking for different things when it comes to certifications, right? And so if we could all come together as an industry and align around a common ask to building product manufacturers and a common way for manufacturers to respond, then we can actually start to make progress. So The first step in that alignment is making sure we're all speaking the same language. And the Common Materials Framework is intended to be that language. So I mentioned earlier there are over 600 building and product certifications on the market. The CMF, Common Materials Framework acronym, takes over 150 of these. These are the ones that are most commonly referenced in North America, and structures them and all the specific data points and factors within them that must be achieved for a product to carry that label. And pulling together over 600 of these discrete data points and filtering them through the Common Materials Framework allows us to start to see how and where these certifications we're looking at align with these higher level impacts. So we can start to make decisions based on impact and not just by taking a certification at face value. So let's quickly dive into these 5 impact areas, and then I'll share a little bit more about how this framework is structured. Human health, we've talked about a lot already. I'm not going to go into this too much. I won't belabor this point, but human health is about essentially ensuring the chemicals that are used in products and throughout a product's life cycle are safe for humans. And I'm curious, I think this is the one that resonates most closely with all of us. If you or anyone in your family has struggled with asthma, was mentioned, right? Infertility issues, MCS, thyroid, tons of different environmental factors that contribute to that. So human health is a very important one for us to consider. Climate health, really here we talk a lot about embodied carbon. Again, previous session before us really focused on embodied carbon, which has been the focus of sustainability in many recent years, and understandably so. But I think that I would say we all want to be sure that we aren't falling into a case of carbon tunnel vision and only focusing on carbon at the expense of some of these other impact areas. Next is ecosystem health. So this touches on things like air and water pollution, soil and biodiversity, and habitat degradation. So this is about finding products that benefit the natural systems, air, water, and biological cycles of life. Then we have social health and equity. So this is one I think that is also getting a lot of attention in recent years. If you haven't heard of Design for Freedom, it's an initiative to eliminate forced labor from the building material supply chain. Their first annual summit was 3 years ago, and that was the first time I really learned about how prevalent modern slavery is essentially in building materials. And this is something that, again, if we don't have transparency, then we can't improve. So just asking for those disclosures is very important, understanding where was it made, who made it, what were the conditions in which it was made. And then last is circularity. So you may or may not know that the building industry is responsible for 40% of material use and 40% of waste by volume sent to landfills. So circularity and enabling a circular economy is really all about thinking about optimizing a product for its end of life, making sure that there is another place for it to go, another place for it to be used, instead of just going to landfill. So within each of these 5 buckets or impact areas, there are sub-buckets, and these address not only product-specific impacts, but company-wide impacts throughout a material's full life cycle. So considering if we look at human health, not only the substances that are present when the product is installed and during the manufacturing process, also what it may emit after its usable life when it goes to landfill. And also considering the full supply chain and how communities are impacted where products are produced, extracted, and manufactured. The next level down of this framework, I think, is perhaps one of the most helpful in trying to translate and understand all the different certifications that are out there. And this is a spectrum that the acronym happens to be TACO. I always get hungry when I talk about this. I didn't eat lunch, so it's even worse today. But this acronym stands for Transparency, Assessment, Commitment, and Optimization. And so we heard from the earlier panel about it's really the time that manufacturers who have invested in disclosures and understanding what's in their products and how they're made really now are being pushed to move towards optimization, minimizing some of those impacts, and removing chemicals of concern, right? But it's very important for designers who are asking for certifications and eco-labels to understand, is what you're asking for simply a disclosure, or is it demonstrating a benchmark or achievement of an existing benchmark like red list free, for instance, for human health? So within each of these taco sections, there are specific factors and sub-factors, like the reporting threshold, what granularity of the product's chemical contents were disclosed, is the certification third-party verified or not. All of this information is coming directly from the certifications that are referenced in the framework. And getting into this level of granularity really allows us to start to evaluate a product's impacts much more closely. So not just taking a certification at face value, but actually starting to search for products by their impacts, and again, not just by certification. So again, all of the factors and all of the data points within this larger framework come from existing certifications and standards. And different certifications require different reporting thresholds, for instance. So again, just looking at human health, for a product to achieve the material health credit under Cradle to Cradle, it has to disclose 100% of its contents at 100 parts per million. Whereas if a product has an HPD, it may be disclosing less than 95% of its contents at 10,000 parts per million. So these things are not apples to apples. So it makes it very hard to compare if you have one product that has certain certifications and another has different. How do you know what those things mean? And so across these 5 buckets, across all of these different impact areas, there's over 600 factors from over 150 different standards that are represented in this framework. And again, currently it's primarily US-based standards, but there is an intent to expand this and start to incorporate more international standards as it grows. But this framework gives us that common language to talk about sustainability. And if we go back to that AIA materials pledge that I mentioned, this pledge was introduced as really an aspirational goal for the design community, but without a common language and consistent metrics, there's really no way for us to accurately track how any of these folks who've signed on to this pledge are performing or following up on their commitments. And so there is a huge desire in the industry to set benchmarks and understand, at a project scale, what are all the impacts of, all the materials that I put into my project. And it's not the role, I would clarify, it's not the role of this framework to set those metrics, but without this common language, this common language is essentially foundational to enabling that. And I want to just draw your attention to the penthouse here in this graphic, which what we're building with this framework, a lot of it, I just talked a lot about data and metrics and scoring, but this is really about something bigger. So the outcomes of these efforts and of this building this broader industry alignment, excuse me, they go beyond numbers and data. And this work will result in improved health and well-being of our communities, our planet, and of individuals. It leads to a future that is regenerative, not destructive, where investing in materials and positive impacts is rewarded by the market, and where holistically sustainable materials can become the norm and not the option. So how do you now take all of this information and integrate it into your work? Today, you can search for products by the impact areas of the CMF on the Mindful Materials portal. This is powered by our SaaS technology partner, Ecomedes. And while this portal is in beta, it serves as a stepping stone to demonstrate how we can start to use the product impacts to guide our decision making. But that future vision of this framework is, that it will be integrated into all the tools and systems and platforms that you're using in your day-to-day work, from design to sampling to specification to procurement. And so before we jump into our discussion, I want to leave you all with this statistic that I found really eye-opening, and this is particularly for the designers in the room. If we think about our power as consumers, you all are here in this session around healthy materials and you're interested in sustainability. Maybe you all think of yourselves as conscious consumers. Maybe you're shopping local, buying organic, recycling, right? Well, the impact that you're having as an individual, if you're a designer, that impact is significantly more. So this is from a ThinkLab study from 2021 that essentially the average designer has 26 times the spending power of the average consumer based on what they're specifying for their projects. And designers in a top 100 firm have 111 times the spending power of an average consumer. So what that means is that a single interior designer at a top 100 firm is responsible for an average of $15 million in specifications annually. And so all of you in this room have the power to design a more beautiful world. And I hope the discussions that you all are a part of today and over the rest of this week will encourage you to do just that. Thank you.
Those were 3 great presentations. I loved having that monitor so I could watch along. Do we have any questions from the audience? I have a couple back there.
My firm? We don't. We have actually gone through a whole vetting process to remove LVT from our library. So I would say we have some clients whose enterprise standards are LVT, and when that's the case, we will try to kind of talk to them about, hey, here's the reason why we don't specify LVT, and kind of use that as an educational moment. But that's one of, I would say that that's kind of all the products out in the market right now, one that's been a low-hanging fruit for us to say, hey, let's move away from LVT. We do specify bio-based, PVC-free resilient flooring, but would prefer to use wood or tile whenever possible. But that's a great question. Yeah, so I would say we lean very heavily on research by these 2 lovely ladies' organizations, as well as Healthy Building Network, now Habitable. These are organizations that have a lot of research based in science that talk about specifically the health impacts of these materials. And so and it's similar with carbon, I think the conversation, when you're able to kind of frame the conversation around, oh, well, why is it that you want LVT? Is it because it's more affordable? Well, here's another option that's affordable. Is it because it's durable? Well, here's another option that's durable, and kind of trying to suss out what is the real desire behind that, and then also presenting it as, I guess, if you bring up the conversation, hey, did you know that sperm counts have been significantly declining, and that vinyl, and tying that back to a CEO, it kind of makes them think a little bit differently about it. So I think being able to present kind of understanding where your client's coming from, but then also being able to present some solid research and saying, hey, this isn't just like our preference, this is based on science and based on the way the industry is going, I think gives you a good talking point or a good backup.
Anyone else want to add?
I guess I would tag on the thing that they were talking about in the earlier session, which is the upfront cost might be less, but the long-term cost is where it's gonna bite you. So that's something I think helps clients understand that too.
Yeah, I think Laurel answered that question perfectly too. Yeah, so it's really about especially the part of assessing why do you want it, and here's an alternative. I think designers really react strongly to here's an actionable thing you can do, rather than here's this research, now sit with it and figure it out.
Right.
So that's what our organization is really about, is like I said, on our website, you see a list of materials and it tells you why those materials are there, what those are alternatives for. So it gives you something that you can bring to the table as a designer when you have a client who's really just no, we always use LVT, I just want to stick with LVT, I don't want to try anything new. And it's it's not new. It's something it's new to you, but it's not an experiment. It's a real product that's there that can meet your requirements.
Yeah, I would just excuse me, I'm sorry. The last thing I would add on that is when you get into the conversations about cost, oh, well, this is this cost, your contractor might come back as your value engineering and say, oh, well, this costs 10% more. And the client's going to say, oh, well, I want to save that 10%. Well, what is that 10% over the cost of the whole project? Is it, is that 10% more, $3,000 more? And I think always considering the bigger picture and considering the broader implications and kind of reframing the question or the pushback in that context is helpful.
I find it amazing that this product was just started, factories were just going up 10, 15 years ago. It was the next great thing, and 10 years later, it's the easiest thing to say no to. I feel badly for those companies that invested heavily. Hopefully, they're not here. Were you going to add something?
Oh no, I saw somebody back
Okay.
there, I thought. Sorry.
Another question back there.
think that's something we're all three trying to provide. There's a variety of different types of tools. We've got some decision-making tools, not necessarily for manufacturers but it would be for, this one, the first example that comes to my mind is around flame retardants. So how does a designer make a good decision about a fire-safe and a chemical-safe material? So we have this kind of good, better, best, red, yellow, green scenario that just the designer can walk through and say, oh, if I go down this leg of the decision tree, I have to make these decisions. So that's the kind of thing we've been trying to put together, and I feel like we have some of those. I don't know that we have one specific to LVT, but one of you guys might.
Yeah, we do. If you go on our website under Tools and Guides, healthymaterialslab.org, under Tools and Guides, or if you just go to our website and search LVT, you'll find a variety of resources there. We also, as I mentioned, have a podcast, and one season of our podcast was only on plastics. So there are several episodes that focus on vinyl, and you can sort of hear the storytelling behind that. We also have a YouTube channel, and our YouTube channel has a couple of events that we did called, it was a comedic title. Now I'm forgetting. It was like 2 years ago, but it was like, what's so luxurious about vinyl tile anyway, or something like that. And you can find some talks that we did on this subject. So we have a lot of resources. Not necessarily like a cheat sheet, but I think it's saying the same thing over and over again, essentially. Sure, healthymaterialslab.org. Mm-hmm.
So, for example, a transition from LVT to tile, then something you may have to worry about are antimicrobials being added to the tile. Can you speak to the audience about why those may be problematic?
Yeah, antimicrobials are harmful to human health, but they don't necessarily have to be included in materials, in alternatives. So we really advocate for like linoleum as a resilient floor alternative, which is flax-based and does not contain antimicrobials, for example. So you're not stuck with antimicrobials just because you're moving away from LVT. They're also like adhesives and sealants and things like that that don't contain antimicrobials that you can use. So it's not a guarantee that you have to use products with antimicrobials.
I'm thinking specifically, a lot of tile products have microban added as a topical coating, and I find a disconnect that people don't realize that that's an antimicrobial.
That was the rage as well about 10, 15 years ago. That started becoming.
See it all the time.
Good point. Luxury resilient tile.
Yeah, it's a hard surface resilient. So it's not specifically LVT, but it's a hard surface resilient tile that again does not have the
So I had a quick question. You kind of answered it about LVT, and we've discussed that, but what are some other low-hanging fruits or easily achievable steps that designers can take to design more healthier buildings and with healthier materials?
I could say something about this. So I think like starting with the highest volume material that you're using, so if it's flooring or paint, for example, is an easy way to make a big impact because it's a large quantity of material. The easiest low-hanging fruit, I'd say, is paint, because paint seems very benign, but actually it's plastic, acrylic paint. So you're lining the walls in plastic. According to Earth Action, 58% of microplastics in the ocean come from acrylic paint, just from washing paintbrushes, from dumping, because not all plastics turn into microplastics, but acrylic paint does. So right now there's a lot of great innovation in paint. We highly recommend this paint company called Keim, K-E-I-M, which makes an all-natural mineral-based paint. It makes breathable walls so you don't get mold behind the paint. And it's the same application process as a Benjamin Moore or a Sherwin-Williams and the same price point. So this is a new thing that it didn't used to be the same price point, but because of volume and because of people actually using it, it's gone down. So immediately you've just like, it's a better looking paint, which as a designer is very important. So that's already like great. And then on top of that, you're avoiding microplastics in the ocean. Flooring, as we've talked a lot about today, is a high surface area material. So just changing that out, if you change to, like a linoleum, for example, then it's a biodegradable material. After renovation, it will degrade in a landfill. You don't have to worry about that. It's flax-based, and flax is a good crop for agriculture too, has regenerative qualities. So these are like easy decisions to make that don't affect your budget, that have a huge impact on the environment, and all you have to do is just swap it out of your palette. So when I do consultations with designers, I usually say, like, what's in your go-to palette? And what can we swap out so that every time you have a project, you're like, this is the paint we use, and this is the floor that we use, and this is the countertop, and just start from there. It makes the research process much less daunting, especially like when you're using the same materials over and over again.
Do Benjamin Moore and Sherwin-Williams, are they coming out with anything to address that?
They do have a low VOC or a no VOC option, but it's still, if it's still acrylic is the problem. So, natural paints are made from a lot of different minerals. Potassium silicate is like a binder material that is used in a lot of mineral paints, and there's a lot of companies coming out with that. Keim is just the easiest one to use and the best for the budget, which is why I recommend that one. But there's lime-based paints which absorb carbon dioxide from the atmosphere for up to 2 years while it's on the walls, and it also like absorbs VOCs. There's casein paint, which is milk protein, which is also a good material to use. So yeah, there's a lot of options out there. There's clay-based, which is also, good.
Anything to add?
I guess I would just say, knowing that designers and specifiers, you're by nature really good researchers anyway. You do a lot of research for all the things that your clients are requesting and requiring, and just adding this layer of the things that we're providing in terms of looking to those other tools that might be out there that are science-based is something I would say. And then also just trying, for low-hanging fruit, trying to find your 3 things. These are the 3 things I'm going to focus on for 2024, and trying to really drive those home, some of the things you were talking about.
I'm going to actually respond more to the manufacturer side, or like, because I feel like we have more folks on the manufacturer or distributor side. So I think that to the using the frameworks, using kind of some of the guidance that we've laid out, and thinking about that like taco spectrum again. I'm thinking about lunch after this. Like if I think tile is a good example where it's an inherently non-emitting material, and if you aren't adding antimicrobial coating or other coatings or treatments or sealants that could present human health risks, right, then we've got the human health side kind of covered, right? If we look at climate health and embodied carbon, this is the session before we were talking about, tile may be a heavier or more intensive embodied carbon than LVT, but it can stay on the floor for 3 times as long, right? So how can we make sure that it'll stay on the floor 3 times as long? That's a challenge for the designers, I suppose. But then thinking about some of the other areas, so like social health and equity. Where is the tile made? What about the communities around where the product is made? So I think that how can you lean into all of these holistic considerations to craft a really strong story about your brand and your product that is going to resonate with designers who really are starting to be a lot more discerning than just, we have this eco label, or we have an EPD. They want to know, they want to ask more questions and kind of go deeper and say, okay, but how are you how are you doing more good instead of less bad? And so I think approaching it that way is, you don't have to kind of reinvent the wheel. Use the frameworks that exist out there, use the guidance that exists out there, and say, hey, if I'm doing good in this one area, what can I do in another area, or how can I lean into the story, telling the story of these other impacts.
Yeah, that's great. Yeah, and it's really encouraging to see so many tile and stone manufacturers are switching to renewable energy, which especially for ceramic, it's very, like you said, like has a high carbon usage, and switching to renewable energy really helps, and factories are starting to do that, which is really exciting.
All right, I have one last question, but before I'm going to give myself a shameless plug. Architectural Records April issue, which is here but showing up tomorrow, of course, has a whole feature on sustainability in practice. And in fact, it's got a couple articles on natural stone quarrying and stone as a structural element. And we do a conference every year on sustainability. So check that issue out. Hopefully it'll be here tomorrow. And the last question for each of you is, what's the most exciting innovation you see coming down the pike or already here in healthy materials?
One.
You can give two each. You got time.
Okay, there's a couple. Sorry, we'll just
for
go
it.
down the line.
Yeah.
So there's a lot of research being done in taking the cement out of concrete and the cement out of grouts and mortars and things like that, because cement is very, very bad for the climate crisis, very high carbon emissions, and I'm really excited about those new technologies because I'm seeing a lot of different ways and strategies for that, and the Biden administration is investing a lot in this particular research area. I'm also seeing some interesting things happening with plastics recycling, where it's switching from mechanical to chemical recycling, meaning that it's actually the molecular structure of plastics that gets broken down and then reconstituted again, so that the plastics that we do have trashing the earth can actually be used in a way that where they become like virgin plastics and how they perform. Obviously, plastics is not something we advocate for, but it's everywhere, and we have to do something with it. So. And then we're all about hemp at the Healthy Materials Lab. If you go on our website, you will see we are all about hemp. And that's because, legislation has made marijuana legal, and so there's a lot of innovation happening with hemp materials. And hemp is one of those super regenerative agricultural materials that has a lot of properties, especially when combined with lime. It can do so many things for the end user as well as for the environment.
If you go to the Mass Timber Conference, 25% of the exhibitors are hemp products.
Yep, it's like blowing up.
Yeah.
Yeah, and actually the Biden administration is
Farm
also
Bill.
investing in that. Yeah.
I guess what I would say for new things happening, one is the PFAS research that I mentioned earlier around textiles. So all the things, biophilia is coming full circle, because all the things that we do as either manufacturers or specifiers requesting things for things that are moisture wicking and things that are resistant to all these things, we're realizing might have some health-related issues with them. So that's something that I guess I'm cautious about that's on the horizon. We don't have all the data in on that yet. The other thing I would say is, if you guys remember the slide that I showed that talked about the results of our research with extreme heat, and you noticed that flooring was the one that came up in yellow, and there were all these different, a lot of the ones that you compete with, are having issues, and in extreme heat, they have a lot more TVOCs and total aldehydes. So in this next phase of research, we're going to be adding stone and tile to that research. So I think that's pretty innovative, cutting edge, and we don't have the findings yet, but we anticipate that they will perform better, depending on the grouts and the sealants and the other pieces. So that's kind of cutting edge to me, innovative.
Very.
I personally am very interested in of all the impact areas, circularity is the one that's nearest and dearest to my heart, and I just recently learned about, one was a lighting manufacturer that can 3D print lighting fixtures, and they will literally can roll up a big tractor trailer truck full of 3D printers onto the job site and print all the light fixtures for the job site right there. So to that point of localizing things as much as possible, which is tough with tile and stone because the products are coming from all over the globe, right? But then I think the interesting challenge, I would say, for the tile and stone industry is that what happens at the end of life. And so I'm curious to see what kind of innovations for, to enable a more circular product category, essentially, because it is wonderful that tile and stone can last for so long, but, in the corporate office world, we're renovating an office every 5 years, and if that tile isn't the right color or isn't on brand with the new tenant that's coming in, then it doesn't matter how long it could last because it's going to come out. So I think that, the more that we can find, take the materials that are otherwise going to go to landfill and turn those into raw materials to create something new, I think is where I'm really excited to see the industry go.
You mentioned taking the cement out of concrete. That's what Jeannie Gang's building in Denver, Populous, isn't? I think that's like the first carbon-free or net zero concrete building. And I think it's that new technology.
I think it's Prometheus. Yeah, cement. It's like microbes that are inside of the concrete instead.
Interesting.
I think that building.
Yeah. I mean, it's getting a lot of press, and it's just being finished, I think, or it may have just finished. But we had a conference once where three architects were talking about building materials, and one of them looked down the room and said, "I hope nobody's in the concrete industry here." And he said, because that's the most unsustainable product in the world. And I'm sure somebody in the concrete industry heard that and said, let's make it sustainable. Mm-hmm. If you can make plastics work, you can make anything work. Mm-hmm. That's key. Mm-hmm. So if we have no more questions, I guess it's time to thank you for coming. Thanks to our panelists. You guys were great. Really appreciate it. And have a great rest of your week at Coverings.